All right, I'm on location in my backyard to record a short video on uniform circular motion. So uniform circular motion is when an object moves in a circle, and the part that's uniform about it is its speed. So if it is moving in a circular path at steady speed, it's in uniform circular motion. So I have a 200-gram mass here tied to a piece of twine very safely. And I'm gonna put this into uniform circular motion over my head. And I want you to think about a couple of things. First of all, what would the force diagram look like for this mass as it spins in uniform circular motion? It is actually accelerating because its direction is changing. So it's not going to be accelerating in the sense that its speed is changing. It's not speeding up or slowing down. But since velocity is a vector, if it's changing direction, it's accelerating kind of in a different sense. So take a look. So to put it in uniform circular motion, I have to spin it at steady speed. I put my phone down on the ground. I'm also going to show you what this looks like from below. This might help you see that the force is always inward. The tension force is inward. And I want you to think about, there are three things that actually make the amount of force on this be bigger or smaller. And I can feel the force because the string has a tension force in it. And I want you to think of three things I could do to make that tension force bigger. And you can pause it and maybe think for a moment. So the first thing I can do is spin it faster. I can feel the tension force go up when I spin it faster. So speed plays a role. The other one would be change out the mass, make the mass something bigger. If this was a 100-gram mass, it would be easier to spin. I wouldn't need as much tension force to keep it spinning. And then the least obvious one is the radius of spin. So if I make the string smaller and try to spin it at the same speed, I can actually feel the tension force is higher. And that's because the change in motion is more extreme. It's going along a sharper curve, so it requires more force. If I spin it out at a nice wide radius, I can feel that the tension force doesn't have to be quite as high. One other thing I want you to think about is if I wanted this to fly off towards the fence, I want you to think about where I would need to release it and make a prediction, and I'll try to make it happen. I'm going to cheat by turning this way. So I let it go as it was moving back towards the fence. As soon as I removed the tension force, I was no longer keeping it on that curved path, and it flew off in a straight line in its current direction. Of course, gravity pulled it down to the ground as well. So I've gone and I've picked up my mass. I'm going to swing it in a vertical circle this time. And again, I want you to think about the forces acting on this thing. So to keep something in uniform circular motion, it needs to have a net centripetal force. Centripetal means center seeking. It needs to have an unbalanced force towards the center of its curved path to keep it moving along that curved path. So I'm going to go ahead and swing this in a vertical circle, and we'll talk about that a little bit. So now I'm swinging it this way, and I can feel the tension is higher at the bottom than it is at the top. And that's because gravity is playing a role. When it swings through the bottom, gravity is pulling it downward, but I need to have a net force that is centripetal towards the center. So the tension force actually has to be bigger than gravity to keep it moving along that curve. When it comes around the top, gravity is now downward. It's providing some of that centripetal force that it needs. I'm swinging it fast enough that it stays taut. There's still a tension force there, but it's not quite as big at the top as it is at the bottom. And that's because gravity is centripetal when it's up at the top of the arc. So it feels a bigger tension at the bottom because it has to overcome that downward gravity, and at the top the tension is somewhat less because gravity is providing some of the downward centripetal force at that point.